It irritates me, but, you know, just school district would just give me what I need, then it would be easier. But I fight him instead. Okay, moral of the story here, we always want to try to isolate the square root, isolate the radical. So it's not always a square root, it could be a cube root, a fourth root, etc. But we're always trying to get that radical by itself on one side of the equation. So on this first one, we do that by subtracting 3 from both sides. So we get square root of 2x minus 3 equals 5. And then to undo the square root, remember in that little elbow, that's called the index right here. That's the index. Also I call it the elbow. It's always a 2 if there's nothing there. It's like if it's just an x, it's always to the first power. It's the same kind of thing here with the square root. So to undo that, what we have to do is square both sides. And then we get 2x minus 3. So when we square, it just makes the square root go away. 2x minus 3 equals 25. Then add the 3, divide by 2, x equals 14. Always I encourage you, what I just did mentally, I encourage you to try to do yourself. It just helps you to catch those careless errors. Because when I was helping you guys answering questions during the test, what I noticed is, and I've always noticed this, but it was just like stuck out like a sore thumb, so to speak, is that the amount of negatives you guys miss or careless errors you make is extreme, right? And you know, if I was helping you and I was like, see, you left the negative off from one step to the next, or you forgot to square it, or whatever that mistake might be. So the best thing that I do when I'm taking a test is I'll finish the entire test. Then I go, like, walk all the way to the library and back, trying to clear my head. So whatever I do to clear my head, and whatever you do to clear your head is your own business, right? Like, I might do weird crap to clear my head, think about something strange, to make me not think about that test anymore, because you get so wrapped up in that and so anxious about it, it's hard to kind of let it go. But then I come back, and when I go over the test, what I do is I don't do the math again, I just try to catch my careless errors, right? So it's a really good strategy to do, because if I could get you all to cut your careless errors in half, my overall average in all of my classes would be a full letter grade higher. So take that advice. Finish your test, go take a walk, clear your head, come back and try to find your careless errors. Because you'll get better and better and better at doing it. Try this one on your own. This one's a little bit easier than the first one we did. You should get 6. Right, so again, I encourage you, you can do that in your head. That entire problem, you can look at it and try to do it in your head. It's always good. Again, you might catch a little mistake. Just waiting for the pencils to stop moving. I'll start solving it up here too. So again, that's the second root. You don't have to write that. I just like showing it because then you can tell why these two cancel, and you're left with 4x plus 1 equals 25. There's a beautiful 2 there. Subtract 1, divide by 4. 4x equals 24. X equals 6. So these are the easy ones. So now we get fractions as exponents. Yay, good times. So we have to cut down the curriculum and our crazy doing all of Algebra 2 in one semester method we're using here. So I cut out the section before this because I feel like this one's more important. And I can kind of teach you some of the stuff from the previous section as we do this one. That fractional exponent is what that last section was all about. So first thing I'm going to do is get rid of that 3. So we get x plus 1 to the 2/3 power equals 4. So off to the side here, I'm going to show you 2 different ways to write the left side of this equation. So the denominator of the fraction goes to the index or elbow, and then x plus 1 is underneath the radical. So I can write it like that with the squared underneath the radical, or it's the exact same thing if I write it like this. Right, so I can square, basically what I would do on this one is I would cube root whatever I have underneath here first, and then square that number. Whereas this one I would square what I have underneath, and then cube root that. So it depends on the numbers and how they work out, which one's more advantageous. But that's a good flashcard opportunity, right, to understand that these two are the same. So same thing on this upcoming test, use of flashcards, right? If you need more, I've got a ton over there. So I'm going to, so the 3 goes in the index, the 2 is underneath or on the outside. So we're going to write cube root of x plus 1. I'm going to write it squared like that. So I put the squared on the outside because I can square root now, because 4 square roots evenly. That's why I put the 2 here as opposed to underneath. But you can totally do it the other way. It still works. So now I can square root that whole thing. And as soon as we square root, remember in the red there it says check for extraneous. As soon as we square root, because of the plus or minus, that's what introduces that second x value as the solution. So this squared gets rid of the squared. So what we have left is the cube root of x plus 1 equals plus or minus 2. So I want to show you the same problem doing it the other way, just so you can see kind of how it works out. Because right here, what I'd have to do is make 2 different equations. Let's just show one more step on this. So cube root x plus 1 equals positive 2, and then cube root of x plus 1 equals negative 2. And then I would cube both sides, solve for x. I could also write this one like this, cube root x plus 1, and the squared underneath the radical equals 4. So on this one, I have to cube first. And I'm going to prove to you get the same answer. And then you can determine which way you feel is easier. And sometimes you'll see it's going horribly wrong, or you end up with this gigantic number, and then you might want to try a different method. So we have x plus 1 squared equals 64, which is 4 cubed. And then we can square root. As soon as we square root, that's what makes that plus or minus. So we have x plus 1 equals plus or minus 8. So, this one looks easier to me than dealing with the cube root, but it's still not that big a deal either way. So here we got to make the 2 equations 1 plus 1 minus. So x plus 1 equals 8. X plus 1 equals negative 8. So this one, you subtract 1, x equals 7. This one, x equals negative 9. We won't do this again with the 2 parallel examples, but it just helps you to see how you can do it 2 different ways. So on the left equations, we have to cube both sides. we'll just do it all the way. So when I raise it to an even exponent, the negative goes away. When I raise it to an odd exponent, the negative stays, right? So if you think about -1 cubed, -1 times -1 is +1, times that additional -1, that's why the negative stays. So this over here becomes -8. So x plus 1 equals -8. And now we're at the same place we were right here. Right? So here we have x plus 1 equals +8. So I think this one on the right is easier than this one, but whatever, it's kind of the same thing, right? It's no big deal either way. So the fun part is when you have two answers, you have to check your answers. So we take those two answers, 7 and -9, and we plug them all the way back into the original equation up here. Okay, so 3 times x. Actually, I'm going to plug it in to this one right here. I'm going to plug in the 7 and the -9. So let's just copy this. So if I plug in the 7 plus 1, actually let's write it like this. Cube root of 7 plus 1.
It's -7.
-7.
What?
+7, -9.
I thought it was called
Hold on.
-7.
Can be okay.
I'm so confused.
You just missed a sign somewhere. You good on this? Okay. It's good. See, Sophie gets mad when she doesn't get it. That means she cares, so that makes me happy. Okay. Do what's underneath the radical first, right? 7 plus 1 is 8. Cube root of 8 is 2. 2 is not equal to 4. So when we plug in the -9, it's cube root. Is it equal 4? I feel like something's going on here. 4, that's right, plus 1. It's all good. That's good. Okay, so cube root of -8 is -2, which also does not equal 4. So your answers are either both work, one works, or neither works. So in this case, neither work. Yes?
So to get rid of the two with the exponent, we just started it.
Oh, that's what I forgot. I knew I forgot something. What did I forget? What's my mistake? Amanda? 2/3 exponent, so I got the 3, I forgot the square, right? So this thing, I knew something was going on, I just couldn't figure it out. So this is squared, this is squared, this is squared. Right, catching your stupid mistakes. I could sense something was wrong. This does equal, so 4 equals 4. I thought both of them worked here. So -9 does work, and then this one's going to work too, because it's squared here, here. So 4 equals 4. Right, so it's okay to screw up in the middle as long as you can catch your mistake. And if you see both of them don't work, it happens. There's one example we do on the last section of this chapter where we do all this work. It's like twofold of these screens worth of work, and neither solution works. And you're like, that's fantastic. I just did a whole bunch of math for nothing. You didn't do it for nothing. You did prove it didn't work. Okay. All right, we get it? Yeah, still writing. Give people a minute. So think about the kinds of flashcards you want to make, right? You just experienced that test, so you saw the weakness in your flashcards, like stuff you forgot, things you need to remember. Yeah, write that one down. Make sure you got your graphing calculator out. We're going to start using that. Anyone need to borrow one? You guys are always good. 8th period, many students need to borrow. So again, we're trying to isolate that radical, first step, right? So I have to subtract the 1 first, and then divide the 3 next. So we get 3 times the 5th root of x plus 1 cubed equals 24. So how do you know when you have extraneous solutions to check or not? When you have 2 answers, check. When you have 1 answer, don't. You can always plug it in to check to make sure you got it right, obviously, right? But when you have 1 answer, you don't have to check for extraneous solutions. Next step here is to divide by 3. So we get the 5th root of x plus 1 cubed equals 8. So anytime I start doing topics like this too, it's always when I get that, when are we ever going to use this? Never. Straight up. For my class, for the quiz, for the test, pre-calc, if you take that, you'll have to take some kind of math class in college. You'll use it again then, and then probably never again in your life. Okay. We got to get rid of the 5. Right, so it's the 5th root. We get rid of it by raising it to the 5th power. That's like the opposite. So raise this to the 5th power. 8 to the 5th power is a gigantic number. So again, I could rewrite it. So this 3, where the 5 is, and I would end up cube rooting 8. So you can do it that way too. You can do it either way. So I'm going to raise 8 to the 5th power, which is 32,768. So, get x plus 1 cubed equals 32,768. And you'll get big numbers on this, so don't, you got a calculator, who cares? Cube root both sides. So if I were to take an even root, then I have to do the plus or minus. If I take an odd root, 3 is an odd number, you don't have plus or minus. What a good thing to write on a flashcard, okay, in case you forget that. So if I take an odd root, 1 solution. If I take an even root, plus or minus. Odd root, 1 solution. Even root, 2 solutions. Whichever way works best for you. So we're going to cube root 32,768. Handy thing on the graphing calculator, 2 cube root, you do math, number 4. And then if I don't want to type 32,768 again, I can go second negative, and it'll just use my previous answer, and I get 32 when I cube root that giant number. So cube root of 32,768 is 32. Subtract 1. So I don't have to check because I got 1 answer. Question? No, because I'm taking an odd root. That's why it's not plus or minus. If I did square root, then it would be plus or minus 32, and I have to make my 2 equations. Okay, fun's just beginning. Just waiting for a couple of people to finish reading. I'm not doing that one. Are we doing that one? Let's do this one. So write this nasty formula down. When are you going to ever do this? If you want to know the volume of a crater, then you're going to do it. Are you ever going to do the volume of a crater? Hell no. Of course not. It'll be probably 4 or 5 lines. Okay, so we start here with this equation. I want to get the V by itself first. We did these at the very beginning of the semester. They're called literal equations, so it's like the second section I ever taught you. So we're kind of coming back to that. So to get the V by itself, a bunch of crap's in the way, right? The 2's in the way, the cube root's in the way, and the divide by 0.3's in the way. So we're going to do the opposite of each of those. First thing I'm going to do is divide that 2 out. So we get d over 2 equals cube root of v over 0.3.
Wait, Evan, can you go back to the formula?
Yep, this is it right here. I just divided by 2.
No, go back up.
Right, same thing. When I wrote the same. Okay, so d over 2 equals cube root of v over 0.3. Then I'm going to cube both sides to get rid of that cube root. So on the left, I have d over 2 cubed equals v over 0.3. So I think it's easier to solve for the variable first. Some students like to plug the numbers in and then solve for the variable. It gets messy when you do that, so in my opinion, this is the easiest way. If you want to plug in and then solve, good luck. So 0.3. So v equals, because all I have to do is plug one number in and it can throw the entire thing in the graphing calculator. So no 2 answers, right? We're odd exponents here, so no worries. And then d stands for diameter. So we got to go back and look at our original equation. I want to make sure everyone gets done right in that though. So we go back and look at our beautiful picture here. So it says the crater is 1.2 kilometers wide, but the volume's in cubic meters, right? And that d has to be in meters. What do I have to do to the 1.2?
Convert.
How? Divide or multiply by 1,000? Multiply by 1,000, right? Because kilometers is the bigger unit. There are more meters in a kilometer, so when we change it into meters, that should be a much bigger number, right? So when I multiply by 1,000, we take that decimal and we move it 3 to the right. So 1.2 times 1,000 is 1,200. So we're going to plug in 1,200 for the d. So 0.3, and we can show that little step. 1.2 times 1,000 equals 1,200. So you know where that 1,200 came from. Volume of a crater, small number or big number? Big number, right? So if you end up, first time I did this last period, I ended up with like 0.06. And you know why? Because I forgot to convert right here, right? I left the 1.2, and then I was like, I saw that answer, and I was like, that can't be right. It's a volume of a crater. right? So let's throw this in the graphing calculator. I'm just going to use 600 right here, right? Because 1200 divided by 2 is 600. And then cube that. So 0.3 times 600 cubed. Isn't that amazing? That's a big number. 1200 divided by 2. So 64,800,000. 64,800,000. Not 45. 64,800,000. The units were, volume is always cube, so cubic meters. You could write meters cubed, it doesn't matter. But you just got to remember units. So that makes sense, right? 64 million cubic meters, right? Meters just about 3 feet. You saw that crater, it's gigantic. So that number makes sense. So you're always doing that double check kind of thing in your head, doing some steps in your head to try to figure things out. Understanding it's a gigantic number. So now when we took square roots, we introduced the extraneous solutions. This time we're going to have to square instead. We also introduce extraneous solutions. Because when we square x, it goes from x to x squared. And as soon as we have x squared, we have 2 solutions, like you guys have learned. Right? X to the 4th, 4 solutions, etc. So first step here is to add 5, and then we square both sides. But I'll wait for people to finish writing that thing down. Anybody feel like they needed more time and they didn't get enough time on that test? Like if you want to come to access time and like look the test over today, totally fine. I'll be here for access time. I already have like 5 or 6 kids coming in. So it's totally open invitation for anybody in here. Right? You want to just look things over, you can do that during access time. Okay, so we're going to add 5 to both sides and then square things. So we get square root x plus 7 equals x plus 5. You cannot distribute the 2 because we get a binomial in the parentheses. So the most common mistake I see students make on problems of this nature is they will distribute the 2 and say it's x squared plus 25. It is not x squared plus 25 because this right side becomes x plus 5 times x plus 5. So you could box that, right? We can do it like this. I'll show you 2 different ways to do this. You choose what you like best. So we can box this. We get x squared plus 5x plus 5x plus 25. And it's gone. So we get x squared plus 10x plus 25. So that's one way you're familiar with. This is the way I like to do it, because it's way faster. Now this method only works when it's just x at the beginning of each parenthesis. So I square the x, I add the numbers, and I multiply the numbers. That's easy, right? Again, it only works when you just have x at the beginning of each parenthesis. If I had like 2x here, you can't do that method, okay? But it's super easy if you do that. Add the numbers, multiply the numbers, no biggie. All right, so Let's get back up there. So we got x plus 7 on the left. And we've got x squared plus 10x plus 25 on the right. So you have an x squared, you know you're going to get two answers, so we're going to have to check. Anytime we get two answers, you got to check. So we're going to subtract x and 7. Maggie's extra excited about checking them. I can feel the joy. So x squared plus 9x plus 18. Your friend and mine, McCross. What goes on the sides? 3 and 6. Again, if you're not good at coming up with those, 18 divided by x and y equals second graph to see the factors. And a lot of times when you guys look at the factors, you're able to come up with those. So 0 equals x plus 3, x plus 6. So x equals, if we set both of those parentheses equal to 0, just opposite signs, that's it. So negative 3, negative 6. Two answers, got to check. So negative 3, negative 6. We're going to plug it into that beast all the way up there. Copy that to a new page. Plug in negative 3 first. Plug in negative 6 next. So we can simplify what's underneath the radical 4. Square root of 4 minus 5. See if that equals negative 3. The right side here, square root of 1 minus 5. See if that equals negative 6. So on the left here, we get 2 minus 3, which indeed 2 minus 5, rather. That'll work eventually. 2 minus 5 is negative 3. So that one works. You just put a check. You could just leave it as equal to and the other one not equal to if it doesn't work. So this one is 1 minus 5, which is not negative 6. 1 minus 5 is negative 4, not equal to negative 6. So again, both could work, one could work, or neither. And when it's neither, that's when you get mad at me, and that's when I laugh. Right? You did all that work for nothing. Yeah.
I checked that differently, but like I still got the same answer.
How would you do it differently?
I started by subtracting or adding 5.
Adding 5? Yeah, totally works. And these were different, right, at the end?
Yeah.
Yeah.
Okay.
So if you definitely can add the 5 if you like to do it that way. And sometimes I will, depending on the problem, right? So if I could plug into this step right here, or I could plug into this step right here, right? That's fine too. Plug in the negative 6s and the negative 3s there. Not doing that one. All right, last one. So we'll do this one together. I'll show you the one on the next slide. This one is definitely going to be on your quiz and test. So write that, on quiz and test. Yeah. Yeah, for sure. So 2 square roots, that's when it gets ugly. Okay? But I think it's kind of fun, but I'm a math teacher. I just wanted to hear Maggie snort back there. First thing I got to do is add that square root of x. So we get square root of 2x plus 1. It doesn't look that bad, and then you'll kind of see what happens. What's my next step? Square both sides. Like, it's the only thing you can do, right? So you look at it and you're like, guess I'll try to square both sides. Sure, that's going to work. So when we square that thing, don't distribute again. So if you need to write that again because you know you're going to make that mistake, write don't distribute on there. So on the left here, we end up with 2x plus 1. And then on the right, I'm going to box this. So square root x plus 1 times square root x plus 1. Good times. So let's talk about what happens when you do square root of x times square root of x. So just satellite information. What we end up with is square root of x squared, which is just x. So if I ever see square root of x times square root of x, I just write what's underneath the radical, right? Because that's kind of how it works. So if you had square root of 2 times square root of 4, we'd have square root of 4 here, which is 2. So if I see square root of 2 times square root of 2, the answer is 2. Okay? So this is x. This is plus 1 square root of x. This is plus 1 square root of x. I know from teaching this for the last 15 years, if kids write this 1 right here, they're more likely to get this problem correct. Right? Because I could have just written square root of x. But when you guys add those and you don't write the 1, you tend to tell me that when I add these two, I get square root of x, not 2 square root of x. Okay? So that's why those 1s are important. And then we have plus 1. So on the left side, we have 2x plus 1. On the right side, we have x plus 2 square root of x plus 1. So we did all of that just to get rid of one of those square roots. Now we got to get rid of the other square root. So we're going to try to isolate that radical. I just want people to be caught up right in this. So I'm going to subtract x and 1 from both sides. And this one actually works out pretty nicely, which means they won't always work out pretty nicely. And I'll show you why. So we get x on the left. That's the nice part. And 2 square root of x on the right. So I have two options here. I could divide by 2, or I could just square both sides. It's easier if you square both sides. You can still get to the correct answer regardless of which way you do it. But it's definitely easier to square like that. And then I have to square both pieces in those parentheses. So 2 squared is 4. Square root of x squared is x. So you have x squared on the left and 4x on the right. This should be easy to factor. Because it's easy to factor, it's not. You guys make it harder than it actually is. So don't do that. We still get to check both answers. Don't forget about that little joyful moment. Right? So we have x squared minus 4x equals 0. What's the GCF? X. Question first? Say that one more time. We're going to right now. Because we have two answers. If I divided the x at this point, it would go away, and then we'd only have one answer. Right? So that's a great question, but you have to keep that like this. So when I divide that x out, I have x parenthesis x minus 4. So I could divide that x out here as well, but again, it would go away, and I would have only one instead of two answers. So what I do here is, like we have for the last chapter, is just set each section, each part equal to 0. So x equals 0 and 4. And that's what we're going to plug in all the way back up to the original equation. Joy and happiness ensues. So I'm going to grab that original equation way the hell up here. And plug in my 0 and plug in my 4. I like plugging them in at the same time, because then you kind of get in a rhythm plugging them in and you're less likely to make careless errors. So if I've mentioned careless errors like 28 times this class period, you should be aware of the careless errors you can make on these kinds of problems, because all sorts of crap happens. On the left here we get square root of 1. Square root of 0 is meaningless. Square root of 1 is 1. 1 does equal 1, so 0 works. On the left one here, I get square root of 9 minus square root of 4 equals 1. 3 minus 2 equals 1, so they both work on this one. So again, both can work, one can work, or neither can work. I don't think they give you any one where neither works in this section. It's 2 sections from now. So again, this chapter, 3 sections, and you're going to be tested on only those 3 sections. Now I'll tell you, that last section is like a mind bender. Okay, it's nasty. This would be what I think is the easiest of the 3 sections. So, write this one down. I'm not going to do it in class, but you guys can practice it. I think this solution is posted in the notes. But if you want more practice, because one of this variety will be on your test, it's a good idea to write that one down for additional practice. And you'll have practice in the homework as well, so it's just one more problem you can have to practice. So you guys got the whole rest of the time to work on it. Your homework is page 395, 9 through 43 odd. Page 395, I'm praying I said it correctly. It is posted already, yeah. Page 395, 9 through 43 odd. So you only have to check, I'll go back, you only have to check when you get 2 answers, because it doesn't necessarily tell you to check, but only when you have 2 answers. That part? Yeah. Okay. Yeah, if you can get all that down, you can write that down. And I'll have the homework displayed in a sec here. So remember, I'm gone this coming Tuesday, so I won't see you guys until Wednesday. Every Tuesday from here through the end of the year, I think it's every Tuesday. I'll be at a golf tournament for varsity golf. We have a sub in here. What I'll do is I'll record the lesson, you listen to the lesson, you take the notes, and you do the homework just like normal. I hope this guy can do math. I got word from Finley that he's a good sub. You guys always tell me if it's a good sub or not. I've got another guy, retired teacher from Boulder High School, I'll use as well. So I'll try both of them, and whichever you guys like best, that's the one I'll try to get each and every time. But if you like this first sub, I think he's younger, kind of chill dude, from what Finley said. His name is Aaron Arthur, Mr. Arthur. Anyone know? No? Okay. You good on that?
Yeah.
Yes.
And I had a question and then and we were working on that and it wasn't like individual.
Enjoy.
Oh, thank you.
I gotta save this, so bust out your device.